today's topic is aldehyde, ketones and carboxylic acids. Before dealing with the aldehyde, ketones and carboxylic acid, we must know what are the carbonyl compounds. Carbonyl compounds are those compounds which contain carbonyl group in their molecule. Carbonyl group means C double bond O group in their molecule. For example, aldehydes are the carbonyl compounds, ketones are the carbonyl compounds, carboxylic acids are also the carbonyl compounds. Other than aldehyde, ketones and carboxylic acid halides also the carbonyl compound because they contain the carbonyl group in their molecule. Amides are also the carbonyl compounds because they also contains the carbonyl group in their molecule. Similarly, esters, they have the functional group COO, are also the carbonyl compound because they contain carbonyl group in their molecule. First of all, the aldehydes. Aldehydes are defined as aldehydes are the carbonyl compound in which one of the free valency of carbonyl carbon is satisfied by the alkyl or aryl group, whereas the other free valency is satisfied by the hydrogen atom. The functional group for aldehyde is CHO, and this functional group it is called as formyl group. Formyl group. For example, CH3CHO acetaldehyde. Again, aldehydes are classified into two main types, that is the aliphatic aldehydes and the aromatic aldehydes. First of all, aliphatic aldehydes. Aliphatic aldehydes are those aldehydes in which the CHO group is directly attached to the sp3 hybridized carbon atom. In acetaldehyde, the CHO group gets attached to the sp3 hybridized carbon atom in the molecule. Therefore, acetaldehyde is an example of aliphatic aldehyde. Second is aromatic aldehyde. In aromatic aldehyde, the CHO group is directly attached to an aromatic ring. For example, benzaldehyde. In benzaldehyde, the CHO group is directly attached to the aromatic ring. Therefore, benzaldehyde is an example of aromatic aldehyde. Second carbonyl compound is ketones. Ketones are the carbonyl compound in which free valencies of carbonyl carbon either satisfied by same alkyl group or by different alkyl group. Here the carbonyl carbon and this carbonyl carbon have two free valencies. If both the free valencies are satisfied by alkyl group, same alkyl group or different alkyl group, then such carbonyl compounds are called as ketones. Again, the functional group for ketone is C double bond O. That functional group is known as carbonyl. Ketones are further classified into two types, that is the aliphatic ketones and the aromatic ketones. Again, aliphatic ketones means the functional group get attached to the sp3 hybridized carbon atom, then the ketones are called as aliphatic ketones. And if the functional group, that is carbonyl group, is attached to the aromatic ring, then the ketones are called as aromatic ketones. Again, aliphatic ketones are further classified into two types, that is the simple ketones and the second one is mixed ketone. Simple ketone means the ketones in which carbonyl carbon attached to the same alkyl groups in the molecule, then such ketones are called as simple ketone. For example, dimethyl ketone. Here methyl group, same alkyl group attached to the carbonyl carbon. Therefore, acetone or dimethyl ketone is an example of simple ketone. If the different alkyl groups are attached to the carbonyl carbon in a ketone, then such ketones are called as mixed ketone. For example, ethyl methyl ketone. Here two different alkyl groups are attached to the carbonyl carbon. Therefore, ethyl methyl ketone is an example of mixed ketone. Then the carboxylic acid. Carboxylic acid are the organic compounds in which one or more hydrogen atoms from alkane or arene are replaced by corresponding number of carboxylic group called as carboxylic acid. Again, carboxylic acids are further classified into two types, that is aliphatic carboxylic acids and the aromatic carboxylic acid. Again, aliphatic carboxylic acid means the carboxylic group get attached to the sp3 hybridized carbon atom in a molecule. Then such carboxylic acids are called as aliphatic. For example, acetic acid CH3COOH. Here the carboxylic group get attached to the sp3 hybridized carbon atom. Therefore, acetic acid is an example of aliphatic carboxylic acid. If the carboxylic group get attached to an aromatic ring, then the carboxylic acids are termed as aromatic. For example, benzoic acid. In benzoic acid, the carboxylic group is directly attached to an aromatic ring. Therefore, benzoic acid is an example of aromatic carboxylic acid. Again, depending upon the number of carboxylic groups present in the molecule, these carboxylic acids further are classified as monocarboxylic acid, dicarboxylic acid and tricarboxylic acid. Monocarboxylic acid means the carboxylic acid which contain only one carboxylic group in their molecule called as monocarboxylic acid. For example, acetic acid. Di means two. The carboxylic acid which contain two carboxyl group in their molecule called as dicarboxylic acid. For example, oxalic acid. Tricarboxylic acid means the carboxylic acid which contain three carboxyl group in their molecule called as tricarboxylic acid. For example, citric acid. Depending upon the number of carboxylic group present in the molecule, carboxylic acids are classified as monocarboxylic acid, dicarboxylic acid and tricarboxylic acid. And this is the classification of aldehydes, ketones and carboxylic acid. Okay, thank you.